Today we're doing 6-4, solving equations with variables on both sides. The tricky part of today's lesson is that we are going to have, let's say, the same variable on both sides of the equation, and you have to figure out, because there really is no right procedure, you have to figure out how to solve it. Okay, so this is the first time where we're actually going to go through where you might all take slightly different approaches and get to the same answer. There's not one right way of solving these problems from this point forward. So what you have to do is you have to use opposite operation. You have to use the golden rule. What I do to one side, I must do to the other. And you have to know how to manipulate integers. So if I'm subtracting from a negative, or subtracting from a positive, or adding to a negative, or adding to a positive, so we're taking all of the information we've learned, and we're applying it to this one situation, or these situations, for the first time. So let's start with something like this morning. 8x minus 4 equals 6x. Okay? What's the first thing I'm going to do in this problem? Liam?
Distributive property.
Yeah, DP. As I see the parentheses, I'm like, ooh, DP, distributive property. Okay? So, I'm going to go ahead and distribute. 8 times x is what? 8x. I'm going to carry down this negative, or this subtraction sign. And 8 times 4 is 32. And that's going to equal 6x. Normally, we would ask ourselves, okay, let's get x by itself. The problem here is x is on both sides, and it can only be on one side. X, or the variable, can only be on one side of the equation. So, how might I do that? What could I do to get x on one side? I don't have to keep the 6 and the 8, but I have to move one of them. Yeah.
Divide 6, or just the x right by 6, divide it by 8x.
Okay. If I were to, that's a great suggestion. But if I divide by 8x, I have to divide this by 8x, this by 8x, and this by 8x. Because what I do to one side, I have to do to everything. So I'm going to say, let's explore that approach in a couple of weeks. Okay? What could I do here, like to say addition and subtraction wise? Go ahead and take a shot. Yeah.
Add 32.
All right, you want to start with adding 32 to both sides.
Yeah.
Okay? I'll do that. Add 32. What I do to one side, I must do to the other. They go away over here, and now I'm left with 8x equals 6x plus 32. All right, Isaiah, what do you think we should do next?
Just add 6 and 8.
I can't add 6 and 8 because they're not on the same side of the equal sign. If they were, that would be simple. But because they're separated by this equal sign, there's a wall here. The only way to go across that wall is to add or subtract, multiply or divide. And we're not doing multiplication and division right now because that's a whole realm of issues that we don't want to enter into today. It's a realm. Okay. So what are we going to do here? Yeah, Dylan.
Subtract on both sides?
Okay, what can I subtract on both sides?
I don't know.
X.
That's a good question.
Multiple Pedro. I think it's more simple than you might give yourself credit for. Subtraction is the right way to go here. But subtract what? Yeah.
32.
Okay, if I subtract 32, I'm going to put it back where it started. So that's a great guess. But that's not necessarily the direction I want to go.
That's kind of cheating.
I appreciate that. That's very good. Anyone else want to take a shot at this?
So you
What could I-
can't subtract because you have to do it.
I mean, saying go
Subtract
on.
the x's.
All right, subtract what x's? I have 6 of them over here. I can't separate them out. I can't subtract 1x. I could, but this is what that would look like. I subtract 1x from both sides, and now I end up with 7x equals 5x plus 32. I'm not really that any closer to where I wanted to be.
How do you do this?
Well, that's what we have to figure out.
It's all
David.
from my brain.
You just subtract 6x.
Ah. And that is very good, yes.
So you did. I was gonna say that.
If I subtract 6x from both sides, like taking 6 xylophones away from both sides.
Xylophones.
Yeah, xylophones, I start with x.
All kinds of
Okay.
xylophones.
Yeah. Yeah. What is 8? If I have 8 xylophones and I subtract 6 xylophones, how many do I have?
2 xylophones.
2 xylophones. If I have 6 and I subtract 6, I have 0, so that goes away.
When you do equals 32.
And that equals 32. And now it's in a situation where I can solve it.
Divide by 2.
Divide by 2.
Let me get that.
We are matching.
16.
And x equals 16.
Don't even.
So the real trick here was to move one of the 2 sets of variables to the other side using the opposite operation. I'm going to leave that example up.
Yeah.
I get it now. It's pretty.
Let's work with a different example here.
I'll leave it be harder.
No, it'll be really easy, and when we do the assignment, it'll be really hard.
Yeah.
Okay, what do I do first here? Yeah, Casey.
Distributive.
Distributive property.
DP.
DP. DP. It's like, whoa! Shiny object. Okay.
I don't think
It's a raven.
It is absolutely the same thing.
Isn't it like that when you're on
It really is.
If you're on
Unless,
crack,
unless you have a
like
brain
that.
like yours, it's really not. What are you trying to say there?
Amazing.
He's a genius.
He's
You're just
insane.
covering your tracks right now.
He's
You
crazy.
really think weird, crazy, yes.
He's deranged.
Okay, you can relax a little bit on the insults, yeah, just saying. All right, 3 times y, Mr. Brooks. 3 times y.
It's 3y.
Thank you.
Man, that was awesome.
3y. Well, because.
Plus.
Try it, right?
Why? Because.
Why is it always?
Why?
Plus-
Because.
Plus 21.
21.
Okay. I know I need to get the y's on the same side of the equation. There's this invisible wall.
Got you right.
There's 2 ways to do this. So I'm going to actually write this again here. We're going to explore both options. What's the first thing I could do here, Casey? You had an idea?
Yeah, you can add, or no, you can
Can't do anything.
subtract 21 from both sides.
Okay, I'll do that.
Why?
Good job.
Subtract 21,
That's true. That's how you do math.
and I end up with negative y minus 21 equals 3y.
We solved them.
You can subtract y from both sides.
Both
Well-
sides.
Casey, you're very close. That is, you're on the right track. But this is a negative y. If I wanted to cancel it out, what could I do?
Add
I can
y.
add a y. So if I add a y to both sides,
You can add
It'd
more
be
y's
4y.
than you have.
as long as I do it to both sides, I can do whatever.
So I can add
Never
26
do that.
y's.
You can do
I
it.
could add 7 to both sides. It just doesn't get me anywhere. The whole point of adding and subtracting from both sides is to simplify the expression. I could complicate it as much as I want. I could add 300 to both sides. I could subtract 7x from both sides and introduce an entirely new variable. As long as I do it to both sides, I can do whatever. Okay? The reason that we're adding y,
Too many ideas.
the reason we're adding y to both sides is it gets rid of this and kind of puts it in with this one. So now I have negative 21 equals 4y. And how do I solve?
4
Divide by 4. The answer is not pretty, but it is the answer. Negative 21 over 4 equals y.
How'd that become a...
It'd be 5 point something.
how'd it become a
5.2,
negative?
negative 5.25.
How'd
See?
21
I'm
become a
on the right
negative?
track.
I've
I'm on the right track.
When I moved it to the other side, I had to do the opposite operation. So I subtracted 21 from both sides. These cancel. Negative 21 moved to the other side. And there it is.
As a minus.
As a minus.
So it's 21.
So it was minus 21. Okay? Or negative 21. Now, the other approach I could have taken is instead of moving 21, could have added y, or I could have subtracted 3y from both sides.
Equals negative 5.2.
Subtract 3y. What's negative y minus 3y? It's like negative 1, and I'm subtracting 3 more. So on a number line,
Negative
4.
I'm going negative 3 more.
Negative 4y.
Negative 4y.
We just said.
Equals 21.
Equals 21. And then I divide both sides by,
Negative 4y, which would be 5.25.
It's just negative 4.
Wow, way to make things complicated, Casey.
and then it becomes y equals a negative 21 over 4, which is the same thing as that there.
It'd be negative 5.25.
He just says random stuff.
Will we ever have like another variable?
Eventually,
No, like in this school year.
Jelly bean.
Jelly bean, that makes no sense.
How about next year?
next year,
Jelly.
absolutely. Next year, this stuff gets way harder, and you start to include exponents.
Are we gonna
However,
makeup?
If, and I shouldn't say harder, because as you get to it, you will have learned the tools you need to solve it. So, not really worried about it.
So it just gets more complex.
Yeah, they just get more and more complex. All right, take a look. Page 277. Turn to page 270, or turn 278, excuse me. And I'm going to go ahead and put problem number 11 up on the board, and I want you to solve it. Okay, negative k equals 9 times k minus 10. Right now, with the person next to you, see if you can solve this problem right here.
partners.
If you don't, then work on your own.
Yeah.
Work through this. I'll give you a couple of minutes. See what you can come up with.
Let's just see if we get the same answers. Alright.
I'm done. Exact same bracelet. But what did I get? Some little kid stole it and snatched it.
It's like my necklace.
This school has some thieves in it.
Yeah, all kinds of thieves.
We're good
Some of them thieving everything.
Maybe it was oval head missing.
Yeah, it was oval head.
Your cousin.
The oval head doesn't go to gym on Mondays.
What did you say? I said you are.
Oval head's in 4th grade.
Your cousin over it.
I am a boy.
Focus.
I'm done.
Let me see.
I figured it out today. It's alright.
Ah,
Verify this.
let's see
Yeah.
what the next step here is, eh?
You forgot to do it. No, mystery.
No.
Yeah.
Dang it.
Oh,
11's not on there.
No, it's
it's a K.
Yes.
like an X.
All right, I'm going to work through this because we have only about 4 minutes left in class.
What? Did I get it right, Mr. Bowman?
Here's what I want. I want you to watch carefully. And I've seen some very good things on your papers. I've seen your ability to do this, and that's comforting to me. The first thing I would do, okay, is I would add this k to both sides. And the reason for that is if I subtract the 9k, which is what I'd have to do, it becomes a problem of negatives. And I don't like negatives if I can help it.
What if I add?
So I'm going to add k to both sides.
No, it equals 0.
Now, yes, it would equal 0. These become 0 because they cancel out. Okay, if I had a negative 1 and I add 1, that's 0. Negative k plus k, it's 0. So this is 0, and that's going to be 10k minus 90. Now, what I can do is I can add 90 to both sides. And when I add 0 plus 90, it becomes 90 equals 10k. I can divide both sides by 10, and k
could it
equals
be-
9.
Could it be negative 9 too?
It cannot be negative 9.
Because if you did it the other way, where you would subtract 9k.
Okay,
Give
I will.
Give
No,
it
that's great. Let me work through that and see what that how that works out. Negative k equals 9k minus 90. Okay, I'm starting with this step right here. If I subtract 9k from both sides, this is a minus 1 minus 9. That's going to take me from minus 1, I subtract 9 more, negative 10. So it's going to become negative 10k equals negative 90.
Oh man, I didn't get
How's that?
Now-
10. That's why.
No, what? Great question. What's your question?
How's that negative number?
How's what a negative
90.
number? 90? Because it's subtracting 90 here. When I removed the 9k, I did not get rid of this subtraction symbol. Okay, this is the same thing as adding the opposite. Okay, so when I removed the 9k, I still had a negative 90 here that I have to contend with.
That's just minus 90.
Minus and negatives are the same thing.
I know.
So it's
not,
negative
it's not a
90.
negative number. It didn't turn it into a negative number.
No, it is a negative number.
I need to know this. Shut up.
Hey, no. This is the one thing you all mess up the most. Okay? So all of you
Whoa.
need to hear it. If I'm subtracting 80, x minus 80, this is the same thing as x plus a negative 80. It's a negative number. The only reason we put subtraction there is that it looks less messy. Subtraction indicates that you have a negative number that you're working with. Okay? So this is a negative 90. Therefore, it stays a negative 90. And when I divide both sides by negative 10, as I will do to get that k by itself, I have negative 90 divided by a negative 10. Negative divided by a negative is a positive.
That's where I messed up. Is I forgot to do negative 10. I put 10. So I was tripping.